Hello everyone, here is a question based on Lewis dot structure. In the Lewis dot structure for NO2 minus, that is nitriteion, what is the total number of valence electrons around nitrogen atom is? For questions like this, we first need to find out the best Lewis structure possible and then we can count the total number of valence electrons. But to write the Lewis structure, first of all we need the total number of valence electrons in the molecule itself. Atomic number of nitrogen is 7 and therefore the electronic configuration is 1s2, 2s2, 2p3. We have 5 valence electrons in nitrogen and then atomic number of oxygen is 8 and therefore the electronic configuration is 1s2, 2s2, 2p4. We have 6 valence electrons but we have 2 oxygen atoms. So therefore we have 12 valence electrons and then for the negative charge we have to count 1 valence electron. So therefore 1 here. So in total we have 18 valence electrons. So with the 18 valence electrons, let us first write the best Lewis structure. Compared to oxygen, electronegativity of nitrogen is less. Therefore, let's put the nitrogen atom at the center and 2 oxygen atoms on either side. Let's put 1 bond pair between nitrogen and oxygen and then let's put 3 lone pairs around each oxygen atom. If we do that, then we would be accounting for 16 valence electrons in total, but we still have 2 more valence electrons. Let us put that as a lone pair on top of nitrogen. If we do that, then the oxygen atom satisfies the octet configuration, but the nitrogen atom doesn't. Around nitrogen we have only 6 valence electrons. Is this the best Lewis structure? No, it is not. In the best Lewis structure, all the atoms should have 8 electrons around it because both the atoms here are from period 2. So therefore, let's send 1 lone pair to the bond pair. If we do that, then we will have octet configuration for all atoms and based on formal charges, we can see whether this is the best Lewis structure or not. Now we have 8 valence electrons around each atom. Let's determine the formal charge to see whether this is the best one or not. Formal charge is equal to total number of valence electrons in the atom minus total number of lone pairs of electrons in the molecule minus total number of bond pairs of electrons divided by 2. So if we calculate the formal charge for nitrogen, then it is 5 minus 2 minus we have 3 bond pairs and therefore 6 by 2. Therefore, this will be 3 minus 3 and that is equal to 0. So we have a 0 formal charge here. If we calculate for this oxygen atom that is on the right hand side, then it would be 6 minus 6 because we have 3 lone pairs. Each lone pair has 2 electrons and then 1 bond pair. So 2 by 2. So it would be minus 1 for this oxygen. And then if we calculate the formal charge for this oxygen atom that is there on the left hand side, then it would be 6 minus 4 minus 4 by 2. Therefore, this will be 2 minus 2 and that is equal to 0. So we do get the net charge of minus 1 if we sum up everything. But at the same time, for nitrogen as well as one of the oxygen atoms, the formal charges are 0. Therefore, this is the best Lewis structure. Here they are asking total number of valence electrons around nitrogen atom in the best Lewis structure. Therefore, if we count the bond pairs as well as lone pairs, it would be 8. Therefore, 8 is the correct answer here.
By the way, when we write the Lewis structure for ions, whether it is a cation or anion, we usually mention the Lewis structure and then put a square bracket and then mention the net charge. That's the way we specify the Lewis structure of cations and anions, and therefore this is a better way of representing Lewis dot structure for nitrite ion.